Hi folks, this is Sumit and welcome to Acadgild's project session number 2. In our last session, we understood what exactly the project requirement is and what will be the different flow that we will have to take care of. In today's session, we will understand data ingestion and table creation. Okay, so data ingestion as well as table creation. So let's begin, guys. I hope you guys remember in our last session we discussed what are the different tables available, what are the different incremental columns. So as this is not connected with the server, we will have to manually create the table and load some of the dummy data because bank is not going to share the data with anyone. Okay, so we will be creating the table and loading the dummy data. Okay, the complete format will be the same, just the data will be dummy. Okay, so first of all, we will have to create these tables in MySQL. Okay, loan info, credit card info, shares info, and accordingly the various fields will be there in MySQL. After that, from MySQL, we will be running a scoop job to import the data into Hadoop. Once the data is imported into Hadoop, we will be creating some stage table like loan info stage, credit card info stage, shares info stage. So the data that is loan info that got imported from MySQL to Hadoop, that will also get loaded into loan info stage. Similarly, credit card info stage will have the data that got imported from MySQL to Hadoop with the name credit card info. So don't worry, I will explain you each and every step. So with your project solution, you will have a file name banking solution execution.odt. It have the step-by-step procedure that you have to take in order to reach your goal. So we will begin with starting of MySQL service and entering into the MySQL. So MySQL-u root-p. This is a command to enter into MySQL. And yes, guys, I have already started Acadgild VM and connected it through putty. Okay. So first of all, I check whether all my Hadoop daemons are running or not. Next, I will check whether my MySQL services are up and running or not. So the command is sudo service MySQLd status. Password Acadgild. And yes, MySQL services are running. So I will fire the first command. Okay, that is MySQL-u root-p password. Just enter. Now let's see what are the different databases available. So there are a couple of databases available. So according to our next solution, we need to create a database named bank. Now when we run show database, you see bank database is available. Then use bank. In order to create any table inside that particular database, we have to use that database first. So database changed. So the first table that we are creating in MySQL is loan info. So guys, are you able to connect the dots with the requirement document? First table was loan info, incremental column, loan ID. What are the various fields in this table? That is loan ID, user ID, payment date, and so on. So you see, we are creating a table loan info with various fields available. So just copy and paste. Now when you do show tables, you have a table named loan info, but data is still not present inside this table. Okay, there is empty set. So we have to create the dummy data from ourselves as well. Okay, inside the MySQL. So we are inserting 4 distinct records. Okay, it might not be distinct, but 4 different records are there. So we are inserting this into our MySQL table. Now when we run select star, we have some data with in-field loan ID, some data in user ID. Similarly, we have data available in our MySQL table. So our first table creation, that is loan info, is over. Next, we will be going ahead with credit card info. You see, this is the command to create a table named credit card info with various fields. Now to show tables, we have credit card info available. Now in this particular table, we will be loading the dummy data. So insert into table value and then the value. So this is the command to insert into your particular table. Now we will check the data, select star from credit card info. Now the data is available. Next table is shares info. Now we will be creating this particular table. Okay, run the command show tables. Shares info is present. Let's load the data in this particular table. Now select start from shares info. So the data is available. So in our MySQL, we have 3 different tables, and in every table there are certain records available. Okay. Now we will fire the command commit to make the changes. Okay, it's a typo. Done. So our next task will be exporting these data, whatever there is in MySQL. We need to import the data into Hadoop, okay, using Scoop. So first of all, we will be creating a different user so that all the functionalities are not given to a particular user. For that, we will be creating a separate user in MySQL by firing the command create user username. So for me, this particular command will not work because I have already created the user. Okay, so I will show you at the end. So I have already executed these steps, and I already have my user, a user named my user available. So you can run these 4 steps easily. Okay, I'll show you. I'll just log out this. So current user, I will check what is the current user of MySQL. It should be root. Sorry, it is not show, it is select. So you see guys, root at localhost. So currently I am logged in as root. Okay, what I will do, I will exit and I will log in as my user that I had created. Password for my user is my user, and you see now if you run the query, select star select current user. So now you are logged in as my user. Okay, let me exit from this. Next step is yeah, hope you guys remember this one. Next was there were certain criteria like data must be encrypted in HDFS, should be compressed, and the scoop password, the scoop job that you will be writing to import the data from MySQL to Hadoop, that should be password protected. Okay, so for that, what we are doing, we are firing this command echo -n within double quotes some value and then scoop MySQL password. So what this command will do, this will create a file named scoop MySQL password. Inside that, it will write the value whatever you have given within double quotes. So my user will be written inside this. So let's fire this command. let's do ls-lrt. You see, scoop MySQL password got created. We'll do a cat on scoop MySQL password and my user. Okay, just a minute, guys. I already had this particular file previously, so let me remove this. Okay, now there is no such file. Now let me run this particular command. Okay, yeah, now it is created, and we will do a cat on scoop. You see, my user. That is something which we inserted from our end. Okay, so now we have our SQL scoop MySQL password available. So we will be using this particular file whenever we create a scoop job to import the data from MySQL to Hadoop. So let's see what is the next step that we have to follow. Okay, so next step is creating some of the directories and then creating scoop job. So see, I have already created the data, and for demo purpose, I'm not going to insert any new record. So I am not going with incremental update. I am doing a simple import from MySQL to Hadoop. You guys, if you have new data and all, if you want to try it out, you can write a incremental import job. Okay. For demo purpose, I just have certain records, whatever I created in MySQL, that's all, that is the record. So I'll be doing a simple scoop import job. So this is the command, scoop job create. So your job name will be scoop loan info and then the connection string. So in MySQL we had bank database, username, my user that we created, table, loan info, password file. So whatever file that we created, that was this particular file, scoop MySQL password file, this we need to give. Okay, the path, target directory we have to give. Okay, so let's copy and paste it. So I hope our scoop job is created and the name should be scoop loan info. Let's fire the command scoop job -- list. This will show you the list of various scoop jobs that you have created. So you see, scoop loan info is already available. Now we need to run this particular scoop job each and every time. I mean, if you write an incremental job, you have to run a simple scoop job to get the incremented data. As in MySQL, I have no incremented data. I will be running this once to import the data from MySQL to SDFS. Okay, so the command is scoop job -- exec and the job name, that is scoop loan info. So let me just cross check. So I have shown you this. Yeah, so this is the command which you have to run to execute your scoop job. Enter. So what will happen, from MySQL table named loan info, your data will get imported into this particular location in Hadoop. Okay, so /bank/loan info stage. So we will just cross check it. Okay, so as I had already executed this one, so it is showing me it already exists. So okay, no problem guys. What I will do, I will remove the directory first. Okay, I have removed the directory and then I will run my scoop job. So this will create a new directory. So I think again, moving ahead, whenever I write a job, you know, I will get the same issue. Okay, no problem. So we will wait till our scoop loan info job is over. Okay, so it's still running. So this is nothing but migrating the data from your RDBMS to Hadoop. So this job is successfully completed, and we will cross check. So what was the path that we gave our target directory? It was /ban/loan info stage. Okay, so the data that was there in MySQL, it got imported. Okay, similarly for our next table, we will write a next scoop job. Okay, so this is for the table credit card info. Go back, execute. Let's check scoop job -- list. You see, scoop credit card info job got created. Now before running the particular job, let me delete the directory first. I would have this. Okay, so deleted. Now I will run my scoop credit card info job. So once this job is completed, we will see some of the data will be there at this particular location in Hadoop. So our job is already running. Let's wait for a minute. Okay, so the job is successfully completed, and then we need to check our target directory, that is /bank/credit card info. Okay, so we will go to this particular location and we will check. Oops, there is some error. What is the error? No such file or directory. Okay, let me do ls. I think name would be different. I'm not sure. Credit card info stage. Okay, there was an extra hyphen, so that was creating the problem. Okay. One. Okay, so the data from MySQL is there in Hadoop at this particular location. Okay, similarly, we will be writing our next job. Next scoop job will be shares info. So let's check scoop job -- list. So scoop shares info job is already created. Again, before running, let me delete this particular directory from Hadoop, which I had created. Okay, it's deleted. So we will run our scoop job. So again, this will pull the data into HDFS at this particular location. Done. Let's check. Okay, so all my data from MySQL have been imported into Hadoop. Okay, you saw how exactly it is done. Now next step is creating external Hive tables. So whatever the tables, for analysis purpose, we have to choose. So we are choosing Hive. You can go with any of the processing engine you want. So what we will have to do is we have to create external Hive tables that will have the data that we imported from MySQL into Hadoop. Okay, so there will be three different Hive tables: loan info, credit card info, and so on. So the first table, first of all, we will create a database, same database in Hive as well. So I'm firing the command Hive to start the Hive shell. Okay, my Hive shell is up and running. So first and foremost, creating a database. Now we will use the same database. Let's see if any table are there or not. Show tables. As of now, there are no tables. Okay, as expected. Now we are creating the staging table. Staging table are the temporary table that we create for any of the purpose. Okay. So as this is an external table, we just need to give the location of data. So the location of data means where exactly your data, what data you want to put. Like if you are creating a loan info table, you can give this particular location. So while creating the data, it will, while creating the Hive external table, the data will get loaded from this particular location. Okay. Similarly, for credit card, we can give this location. Okay, and for share info also we can give that location. Okay, let's see how it is achieved. You see, we are creating a table loan info stage with the same fields. Okay, just that we are adding this particular line location / bank / loan info stage. Okay, it means the data will get loaded into this particular table from this particular location. Okay, let's run. Done. Now if we do select star from loan info stage, you will have the data. So you did not do any load data in path or load data local in path, nothing as such. You just pointed to the location and automatically the data get loaded into external Hive table. Similarly, next we are creating credit card table. Then select star from and the data is there. Next will be share info stage table. So we have three tables created in our Hive. To be specific, three external tables created. Now, the next step is creating the core tables and loading the data into the core tables from staging table. Okay. So what exactly this means is, so as of now, we have created three external tables. Now we will be creating the three table. Okay. And in those three tables, we will load the data from staging table, but while loading, we will encrypt the data as our project requirement said that the data must be encrypted. So we will encrypt the data. Okay. So now you have to add the UDF into Hive shell. So there is a particular UDF given in your project solution, that is Hive UDF.jar. So you need to add this particular jar first of all. Okay, so Let me open another Putty session. Okay, so I have the Hive UDF jar present. So which location? At home Acadgild. Okay, so what I need to do is I need to add the jar. So I will add the jar into my Hive. Command is add jar and the path of the jar. Home Acadgild Hive hyphen UTF dot jar semicolon enter. So now this particular jar is added. Now whatever the function, whatever the class is there, we can create a temporary function and use that. So you see guys, we are using AES encrypt and AES decrypt. So there are two different Java files in your project solution. You will find AES decrypt and AES encrypt. So from the name itself, it is quite clear that AES encrypt.java will encrypt whatever data you pass into this particular field. Okay, so you will have some of the methods. So encrypt method is there. So whatever data you are passing it will use certain algorithm and encrypt. So this is the basic agenda behind this particular code. Similarly, we have AES decrypt. So after the analysis, you will have to decrypt and push the data to your downstream team. So you can use this particular algorithm. Okay. So now we need to create temporary functions. So let's copy this. Okay. Now you see we are creating core table. Okay. We are just creating a table named loan info with the same fields, but in ORC file format, stored as ORC. So this ORC file format is, it is one of the optimization technique. It will compress your data as compared to your normal file format, text input file format, or whatever it is. So ORC is the best file format for the normalization purpose. So we will just copy this and done. Now into this particular table, that is our core loan info table, we will load the data, but we will encrypt the data while loading. You see, in this particular table, we are inserting the data from our loan info stage table. You remember we created loan info stage table and then we loaded the data, whatever we imported from MySQL to Hadoop into this particular table. Now from this particular stage table, we will load into loan info table, but we will encrypt the various fields. Okay, you see we are passing the various field into the temporary function that we created. Okay, so let's copy, paste it. So let's wait for some time. It will load the data in our core table. I will show you how the data looks like. It's still running the job. So basic agenda is the data encryption. Okay, so that it is not in human readable format. This is just the security feature that you are enabling. Okay, so it is done. Now if we do select star from the table that we created, select star from loan info. You see guys, can you check this? Can you decode this visually? No. So the fields that were there that got encrypted. Okay, so we are providing some extra security to the data. Similarly, we are creating a credit card info table, and in that particular table we will be loading the data from credit card info stage, but the data will be encrypted. Yes. So again, this will start a MapReduce job. We have to wait for some time. So basically, these three tables will be available in our HDFS with the data engineer. So they will be performing the analysis in these particular tables, whatever the encrypted, whatever the data table that have encrypted data, analysis will be done on that, so that the data is not compromised. Okay, this is the main agenda behind this. It is done. Again, I will show you the data. Search star from credit card info, and then again it is encrypted data. Okay, now we will create share info table and we will load the data in the encrypted format. So once all these three tables are created, the table that have the data in encrypted format, you can truncate your staging tables. Staging tables were those in which the data was loaded from, the MySQL to Hadoop, the data that was imported, that was there into stage tables. So you can delete or you can truncate those tables so that the data is kept, as a secret. Okay. The data is not compromised, so we will be using our encrypted data tables. Select star from shares info, and this is also encrypted. So we have reached to the end of our data ingestion and table creation phase. In our next session, we will go ahead with the analysis part. Okay, till then, take care. Thank you.